In this video, we're going to graph this, this function I have here, this rational function. Okay, so let's go ahead and get started. The first step that you should always do is see if you can factor. Alright, so let's see if I can factor this. Can I think of two numbers that when you multiply them together you get -5, and when you add them together you get -4? So what about -5 and 1? So let's go ahead and write that as a factor. So +1 and x minus 5. Okay, you multiply those two numbers, multiply 1 and -5 together, you get -5. Add them together and you get -4. Okay. On the bottom, can't factor that. Alright, the reason I factored is to check to see if anything canceled, and if something did, then that would be a whole. Alright, so nothing canceled, no holes. That's good news. So I'll just write that here. No holes. Alright, step 2 is we're going to find the intercepts. So x and y intercepts. Alright, so let's go ahead and do that. Let's get started with the x-intercept. And to find the x-intercept, you plug in 0 for y and you solve. So, it's actually, it doesn't matter if I write the original function or the factored function here. I'm going to go ahead and write the factored function because it's a little easier to solve this that way. Alright, divided by x minus 2. And for the x-intercept, so this will zero out when x plus 1 equals 0, or if x minus 5 equals 0. So x equals -1 or x equals +5. Okay, so my x-intercepts then are going to be -1, -1 comma 0, and 5 comma 0. Alright, so let's find the y-intercepts. Plug in 0 for x. So y equals, and then plug in 0 for x. So that would be 0 squared minus 4 times 0 minus 5 over 0 minus 2. So that would be, this is 0 and that's 0. So that would be -5 divided by -2, which is 5 halves. Okay, so the y-intercept is 0, 5 halves. Okay, so the next step is to find the asymptotes. Go ahead and bring some of this information over to the next page and we'll start finding the asymptotes. Alright, so I took some of the information over and now I'm ready to find the asymptotes. So let's see. Let's start with the horizontal asymptote. I think it's one of the easier ones because it's just those rules. We just need to know the degree on the top and the degree on the bottom. So the degree on the top of this right here is 2, right? The highest power of x is 2. And the degree on the bottom is 1, right? So n equals 2, m equals 1, and so n is greater than m, right? Which the rule for if the degree on the top is higher than the degree on the bottom meant that there is no horizontal asymptote. Okay? Remember in the previous video I said if there's no horizontal asymptote, that's when you want to say, is there an oblique asymptote? Okay, so we're going to have to look for an oblique asymptote. But before I do that, let's go ahead and see if I have any vertical asymptotes. So let's see, vertical asymptote. I already looked for holes. There was no hole. So I just need to find when the function is undefined. So when x minus 2 equals 0, the function f of x will be undefined. So x equals 2. So this is the vertical asymptote. X equals 2. That's the vertical asymptote. Okay, so now let's go ahead and find our oblique asymptote. To do that, I'm going to use synthetic division. So let's take the coefficients on top here. So I have 1, -4, and -5. Let's go ahead and write that. 1, -4, and -5. And then I'm dividing it by, so I'm going to write here the opposite sign of this number. So that's -2, so I'm going to write +2. Alright, bring down the 1. And then 2 times 1 is 2. -4 plus 2 is -2. And then 2 times -2 is -4. -5 plus -4 is -9. Okay, so f of x then can be rewritten as x minus 2, right? I'm getting that from here, x minus 2, minus 9 over x minus 2. Okay? This piece goes to 0 as x goes to positive or negative infinity, so y equals x minus 2 is the slant asymptote, or is the oblique asymptote. It is an oblique asymptote. Alright. Next we need to plot or put in a few points into f of x, and then we'll pretty much have all the ingredients we need to graph. So let's go ahead and do that next. I'll start that on the next slide. Though before we go to the next slide, I realized that there was a little mistake when I can put this over from the previous slide. This should have been 0, 5 over 2 because this was the y-intercept. So I'll be sure to correct that on the next slide. That was just a little mistake that I made there when I copied it over. Alright, so now we're ready to go ahead and find several points. I've copied over all the information that we found from previous slides, the x-intercept, the y-intercept, the oblique asymptote, and the vertical asymptote. So let's just find several points, and let's start our graph. Okay, so when I find several points, I notice I've already put some numbers here in the table. Where did those numbers come from? Well, these two numbers are the intercepts with the x-intercept, so I'll just go ahead and put those. And then also the vertical asymptote, that's where it's NA. Okay, so why did I choose those? Well, because, we already know what's happening there, so let's find what's happening in areas that are kind of around these values of x. So we know what's happening when x equals -1, when x equals 5, and when x equals 2. Okay? Alright, so let's just find some other points. So say when x equals -2, or when x is between -1 and 2. So say, for example, 0. Or when x is between 2 and 5, say 3. Or when x is more than 5, say 6. Okay, so go ahead and plug in these values for f of x. If you were to plug in -2, you should get -7/4, which is the same thing as -1.75. Okay, I'm writing it like that just so that when we're plotting, it'll be easy to know where that is, or approximately where that is. If I were to plug in 0, I would get 5/2, or 2.5. 2.5. Actually 0 isn't a great point to do because, well, we already knew that from the y-intercept. So actually, I'm just going to add one more down here. Let's go ahead and plug in 1 as well. So that's another number that's between -1 and 2. So if I were to plug in 1, I'll get 8. Okay. Alright, so now let's plug in 3. If I were to plug in 3, I'd get -8. If I were to plug in 6, I'd get 7/4, which is 1.75. Alright, so now I'm armed with all sorts of information. Let's go ahead and start graphing this function. Okay, so to start, first thing I'm going to do is I'm going to graph these points that I've found over here in step number 4. So I have -2, -1.75, so that would be somewhere around right there. -1 and 0, okay, and then 0 and 2.5, okay, that'll be right about there, and 3 and -8, okay, so 3 and -8, that's more like there. Let me erase that. Okay, and then 5 and 0, alright, there. 6 and 1.75, alright, that's about right there. And 1 and 8. 1 and 8, that'll be right about there. Okay, now let's go ahead and do our asymptotes. So we know we have an asymptote. I'm going to first do the vertical one, it's easier. X equals 2. So vertical at x equals 2. Okay, so let's draw that there. Okay, and then we have a oblique asymptote. Okay, so to graph this, I just need to graph that line. Remember y equals mx plus b, right? And so m is 1, so the slope here is 1, and b is -2, or the intercept is -2. So let's go ahead and draw that one. I'm going to do this one in red, actually. So I'm crossing here at -2, and then I have a slope of 1. So let's go rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. Okay, let's go ahead and do some points down here too. Drop 1, run 1. Okay. Okay, so this is what my oblique asymptote then looks like. Okay, should be a straight line. Try to make it as linear, you know. Okay, so it's like a linear line like that. Okay. Alright, so now I'm ready to go ahead and connect the dots here. And remember, we're going to be getting really close to our asymptotes eventually, so let's try to draw it so that we're getting close to our asymptotes. We're getting really close here, okay. And then we're getting really close to this asymptote down here. And then we're getting really close to this asymptote right here. Okay, and so draw your arrows to indicate it continues in those directions. Alright, so great. This is the way this graph looks like. So there, I've drawn the graph. Now, one last thing that I want to do here is I want to describe the end behavior, okay, of this graph. So let's go ahead and do that. So let's say f of x equals this x minus 2. When does it do that? It does that as x approaches plus and minus infinity, right? That's basically what the oblique asymptote is. So if we were to, so as x goes to negative infinity, you see I'm approaching this asymptote, and as x goes to positive infinity, I'm also approaching the asymptote over here. All right, and then oh, I wrote that wrong. It should not be an equal sign, definitely not. It should be an arrow. Okay, so f of x goes to x minus 2. It does not equal x minus 2. Okay, then the next one, f of x goes to, let's see, f of x goes to, what's another thing it goes to? It goes to infinity as x goes to, let's see, let's look at our graph. So here's infinity, way up here, right? And f of x, x is going to 2 from the left, right? So 2 from the left. And then f of x, lastly, f of x goes to negative infinity as x goes to, so this is negative infinity way down here. So it's the function is going to that as x goes to 2 from the right. Okay, so that's how you would describe this end behavior of this graph.